His name was Donald, and the experiment that turned him into this began with a question that seemed harmless. In 1931, a young psychologist named Winthrop Kellogg was obsessed with a debate that had divided science for decades: nature or nurture. What makes a human behave like a human? Is it something we're born already knowing? Or is it all learned, shaped by the environment around us? Other scientists tried to answer this with rats in mazes, with pigeons and levers. Kellogg found all of that insufficient. He wanted a definitive answer, and he decided there was only one way to get it. Compare a human baby with a baby of another species, side by side. Same house, same rules, same treatment, exactly equal, from breakfast to bedtime. The problem was, he didn't have two human babies available for the experiment, so he used what he had: his own son, Donald, newborn, and he went to a primate center in Florida to get a 7.5-month-old female chimpanzee named Gua. He brought her into the house, and from that day on, Gua wasn't treated like a pet anymore. She was raised exactly like a child. She slept in a crib, wore diapers, was fed with cutlery, seated at the table, got a bath every day at the same time as Donald, received affection, scolding, routine. Kellogg and his wife measured everything: reflexes, grip strength, motor coordination, problem-solving ability, reaction to sounds, to commands, to stimuli. For weeks, the results seemed to confirm exactly what Kellogg expected. Gua was ahead in almost everything. She learned to open doors faster, reacted to commands with more precision, could use a spoon before Donald could. In some motor coordination tests, she outperformed Kellogg's own biological son for weeks straight. A chimpanzee raised as a human baby, learning faster than an actual human baby. For Kellogg, that was already fascinating enough to publish. The idea that environment shaped behavior so powerfully that a different species could keep pace with, and sometimes outpace, human development in the first months of life. But there was one detail Kellogg noted in his private records and barely mentioned in the published paper, a detail that decades later, researchers would consider the most important data point of the entire experiment, and it had nothing to do with Gua. It was what happened next that changed everything. Because the experiment wasn't just testing whether Gua could become more human, it was testing, without anyone having planned it, what would happen to Donald. And this is where the story stops being interesting and starts being disturbing. Donald, raised alongside Gua, began imitating her, not once, constantly. He started walking on all fours, hands on the ground, the way Gua moved through the house. He started biting objects and surfaces exactly the way she did. He started communicating by clapping and making guttural grunts instead of trying to form words. And then came the moment that appears in that recording. Donald, at 9 months old, wanting food, didn't cry the way a baby normally does. He barked, the same alert sound Gua made when she wanted her parents' attention. Donald had learned to ask for food the way a chimpanzee asks for food. To understand why this happened, you need to understand something about the newborn human brain that most people have never heard of. Babies don't observe the world passively. They actively copy from the very first hours of life. In 1977, decades after Kellogg's experiment, psychologists Andrew Meltzoff and Keith Moore at the University of Washington showed something that seemed impossible. Newborns, less than an hour old, who had never seen their own face, could imitate simple facial expressions of an adult in front of them. Tongue out, mouth open. It wasn't a reflex. It was intentional, almost instant imitation. This means the human brain is born with a system already wired to copy. It's not something that develops gradually. It's one of the first mechanisms to kick in, before speech, before basic motor control. And that system isn't selective. It doesn't know to only copy humans. It copies whatever is most present, most consistent, most repeated around the child. In the Kellogg house for 9 straight months, that source was, in large part, a chimpanzee. Kellogg and his wife realized something no scientific paper of that era had predicted. The experiment wasn't just measuring how close Gua could get to human behavior. It was showing in real time how malleable a human baby is, how much the brain of a child under 1 year old absorbs whatever is around it, without distinguishing whether the source is human or not. Donald wasn't becoming less intelligent. He was developing exactly the way the human brain is designed to develop, copying the closest, most consistent model available. Developmental scientists call this phase a critical period, a specific window in the first years of life, when the brain is extraordinarily open to absorbing language, behavior, and social patterns. After that window closes, that same absorption becomes much harder. That's why children pick up a second language with ease, and adults struggle to do the same. It's the same plasticity that, in the Kellogg house, worked against Donald instead of for him. The experiment ended abruptly, 9 months after it began. The official version, published by Kellogg, cited logistical difficulties and the end of research funding. But the family's private notes tell a different story. A mother, growing more alarmed, watching her own son drift away from human speech and closer to grunts and barks. Watching Donald, nearly a year old, still unable to form a single recognizable word, while perfectly imitating Gua's sounds. They returned the chimpanzee to the primate center, and they never publicly spoke about the darker details of what they had documented. Kellogg spent the rest of his career trying to repeat the study. He never got funding again. No ethics committee would approve something like this today, and it's easy to understand why. But the most disturbing data point of the entire experiment isn't about Gua, it's about Donald. And what happened to him afterward is the part most articles about this case never tell. Donald grew up. He learned to speak normally a few months after the experiment ended. His brain, outside that environment, went back to absorbing the human model around it. He went to school, had a childhood family described as ordinary. He went on to study medicine, becoming a doctor. He got married. He built a life that, from the outside, carried no visible trace of those 9 months. But decades later, in 1973, at age 43, Donald took his own life. There's no scientific proof that the experiment caused this. He lived more than 4 decades normally after that period. But researchers who've revisited the case over the years keep asking the same question, never able to fully answer it. What does it mean for a person's psychological development to spend the first months of life treated as a research subject and not as a son? No one can prove it for certain, but no one can completely rule it out either. What's left, in the end, isn't just the strange image of a baby barking instead of crying. It's the question Kellogg never imagined he'd end up asking. If a chimpanzee, raised as a human for 9 months, nearly managed to behave like one, and if a human, raised alongside a chimpanzee, started behaving like one too, then what exactly made you? You?